In this final example for Chapter 5, we're going to look at some more general probability examples. Example 1 says, suppose that 5% of players in the NFL have taken an illegal steroid, and also assume that those who have taken steroids have a 99% chance of having a drug test return positive. In addition, suppose that there is a 3% chance that a player who did not take a steroid will have a drug test return positive, and this is known as a false positive. We have two questions to answer about this scenario. A asks, what is the probability that a randomly chosen player will be steroid free and will still test positive for steroids? So to begin with, the probability that a player will be steroid free, well, that is 0.95. If 5% of players have taken a steroid, that means 95% are steroid free. Times, now the probability that they'll still test positive for steroids, that's where this 3% or this 0.03 comes into play. So in addition, suppose that there is a 3% chance that a player who did not take a steroid, that would be these 95%, will still get a test that returns positive. And note this is 0.03 and not 0.3. 0.3 would be 30%, 0.03 is 3%. So it's just a matter of multiplying these two together to get our results. .0285. So in the NFL, according to this data, only about 2.85% would be steroid free but would still get a positive drug test, which would call for another drug test just to be safe. Part B says, what is the probability that a randomly chosen player will be a user of steroids and will test negative? So what's pretty much the probability that you can take steroids and get away with it in the NFL? Well, the first characteristic will be the person is a user of steroids. We know that 5% or 0.05 use steroids. And if you use steroids, you have a 99% chance of a positive drug test, which means you have just a 1% chance of getting that negative result. Very slim chance. There's a 99% chance it goes back positive, which is the true result. Only a 1% chance you get a negative result. And so if we multiply these out, we will get our answer for this question. The result is 5e to the negative 4, 0.0005. Very slim chance the person takes steroids and gets a negative test and gets away with using steroids. Final example deals with streaks. Just a quick side note, streaks are a common occurrence. They're more common than you might think, and they should not affect how you examine future events. Just because a result comes up several times in a row, the probability of the next independent event has not been changed. Because they're independent, they're not affecting one another. In this example, we're going to roll a die 4 times. And we want to see, well, which sequence is more likely to get a streak of 5, 5, 5, 5, or just a random 3, 6, 1, 4? Well, if you were to ask just a random person on the street this question, they'd probably say, well, it's the 3, 6, 1, 4. It would be tough to get a 5, then a 5, then a 5, then a 5, but the math shows otherwise. The probability of 5, 5, 5, and then 5, multiple events. Well, probably the first 5 will be 1/6. You get that 5, but you're still rolling the same die. There's only 1 5 out of 6 sides. Each 5 is 1 out of 6. If you move to the next set of numbers, the one that seems more reasonable, the 3, the 6, the 1, then the 4, well, the probability of a 3 is 1 out of 6. The probability of a 6, there's just 1/6 out of 6 sides. Same for the 1 and same for the 4. It's the identical string of numbers. And if you calculate this, 1/6 raised to the 4th power. Both of these are going to be 0.00077. So don't let the streak fool you. It doesn't really change the probability of the next event. The probability of getting a 5 on the end of either of these strings is the same.